If there was more bright sunlight during the week before the visit to our clinical center, then insulin resistance was improved and we saw some lower triglyceride levels.
humanOS. Learn, master, achieve.
Welcome back, everybody. As you no doubt are aware, insulin resistance is a growing problem in industrialized societies. What exactly is insulin resistance? Well, insulin is a hormone produced by the pancreas that helps glucose from the food we eat or glucose that is made by the liver that makes its way into the bloodstream. Insulin helps this blood glucose enter cells throughout the body where it can be used to make energy. So when blood glucose levels rise, insulin levels rise with it, helping to keep our blood sugar in a normal range. This is normally a smooth running system. However, in some individuals, cells cease to respond efficiently to insulin's signal and fail to take up glucose from the blood. This is insulin resistance, and it is becoming an ever more prevalent issue. About 1 in 3 adults in the United States has prediabetes, which of course is a disease largely defined by the ineffectiveness of the body in dealing with blood sugar. So why is this happening? The causes of insulin resistance are complex and not fully understood, but we do know that physical activity and diet, and by the way, I use the term diet, I mean our dietary pattern, which not only includes the food that we eat, but when we are eating it and when we are not eating, in other words, day-to-day fasting periods. So these things, exercise and diet, play a crucial role to maintain insulin sensitivity of our cells to the hormone insulin. But it's clear that other factors are important as well. And one is light. We know, of course, that at night, exposure to bright light, particularly blue light, is linked to metabolic perturbations. A number of studies have found positive associations between artificial light exposure in the evening and risk for type 2 diabetes. And one experiment by Phyllis Zee's lab out of Northwestern found that a single night of blue light during sleep increased insulin resistance. But what about bright light during the day? That's an entirely different story. One cohort found that subjects who got a lot of sun exposure had 30% lower risk of developing type 2 diabetes compared with participants who did not get a lot of sun exposure during the day, suggesting that sunlight may somehow be beneficial for glucose metabolism. Now, take a moment and think about how much sunlight you've gotten on a daily basis in the last couple of weeks. But the reasons for this connection are hard to pin down. Furthermore, bright sunlight is often correlated with warmer environmental temperatures, and the latter may also be a relevant factor in insulin sensitivity. My guest for this episode of humanOS Radio is Sander Kooijman, a postdoctoral researcher at Leiden University Medical Center. He and his colleagues recently published a paper examining how bright sunlight and environmental temperature affects measures of glucose and lipid metabolism in 2 population-based European cohorts. He is here to discuss these findings and the likely underlying mechanisms with us. So, without further ado, welcome to the show, Sander.
Thank you very much. And great introduction, Dan.
Well, thanks. So how does environmental temperature seem to affect insulin sensitivity and type 2 diabetes risk? What was some of the research prior to you doing this study that made you think that there might be a connection?
That's not an easy question. You already highlighted some clinical intervention studies, but there are also some epidemiological studies. For example, one that was published by our lab already a couple of years ago, where we showed that diabetes incidence and glucose intolerance prevalence increases with higher outdoor temperature. That was basically a meta-regression analysis in the world, comparing different countries, comparing diabetes incidence in different countries, but also looking across the United States. And also even within states, the authors could show that there was an increased diabetes incidence with higher outdoor temperature. And one of the reasons we told about this was around adipose tissue function. We have 2 types of adipose tissue in the body. One is white adipose tissue, and that's basically the one that makes you fat and is generally unhealthy. But we also have brown adipose tissue in our body, and that produces heat. So it uses lipids and glucose to make heat. And that helps us to cope in cold situations. Especially young children or babies do have a lot of brown fat because they have a relatively large body surface compared to their body weight. So they easily lose weight and they really need this brown adipose tissue to keep their temperature up. Adults also have brown fat, and we're not really sure how much it contributes to energy expenditure. If we can activate it, if we can then improve our metabolism, so if we can prevent insulin resistance, we have more and more clues that at least helps.
Right. And it was probably only maybe 10 years ago that, it's a guess right there, but about 10 years where we started to realize that adults actually have more brown fat than we thought.
That's true. Those were 3 papers published back to back, and 2 of them in the New England Journal of Medicine, showing that when you activate brown fat by cold exposure, so that's pretty cold, so you have to cool people down between cooling blankets of 4 degrees. Only that is enough to really visualize brown fat activity using PET-CT scanning.
Let me ask a clarifying question there. When you say 4 degrees Celsius and also lowered the temperature by 4 degrees or to 4 degrees?
It's 4 degrees Celsius, yes. I'm always forgetting that I'm in Europe and you guys are doing it differently. And it's lowering the temperature to 4 degrees Celsius, so making it really cold, so making it 4 degrees of Celsius.
That's like in the 30s for people that are thinking.
I'm glad you're doing it, translation. Yeah, so that was back in 2009. And since then, a lot of groups in the world are studying brown adipose tissue function and activity and see if we can come up with a way to activate it. Because if you can activate it, you can possibly lose weight because you're burning lipids into heat. But you can also improve your insulin resistance because you're also burning glucose into heat. We're now actually looking with many researchers to find strategies that activate your brown fat. And one of them is cold exposure.
I did talk about brown fat once before, and I just remembered it was with Mike West, who is the CEO of AgeX, the publicly traded company that's working on aging interventions. The conversation with him was mostly centered around pluripotent stem cells. But one thing that they're doing is creating a line of different tissues. The 2 that are most advanced are cardiac tissue, and then the second one is brown fat. They would create it in a petri dish, implant it into people, and it, just like you're saying, it would be a way to then theoretically address diabetes by lowering blood glucose, address cardiovascular disease by taking triglycerides out of the blood, address obesity by helping to burn off excess energy. So really promising area. By what mechanisms was it thought that environmental temperature might actually affect glucose metabolism?
There are some data on heat shock proteins. If you expose people to heat instead of cold, you will get activation of heat shock proteins, and it also improves your insulin sensitivity. There's not a real clear answer whether you should cool people down or warm people up. Both can have beneficial effects.
I'm excited about that type of intervention. I have a sauna. It's a great way to get exercise, quote unquote, if you're not feeling like exercising on that day. That's how I think of it. And that the effects of thermic conditioning or going into a sauna, at least in some areas that have been tested, are comparable to what we find with exercise training. So it's exciting.
So my feeling is that short-term heat exposures are pretty good for you. On the other side, so the short-term cold exposures can activate your brown fat, but also what the paper I just described basically shows that if you have long-term exposure to slightly lower temperatures, that also leads to beneficial effects.
Less cold, but longer exposures.
Yeah.
Well, one fairly obvious problem with understanding the effects of outdoor temperature on health is that outdoor temperature is often correlated with outdoor sunlight. Your study sought to separate these effects. Can you describe the metabolic effects of bright sunlight?
What we did was taking 2 European cohorts. What we did is collecting the weather data from local weather stations. So this was in Oxford and here in Holland, in Leiden. We tried to correlate the daily weather conditions to the metabolic phenotype of the people coming in. So these are big cohorts, so people were coming in all over the year. It was quite evenly distributed. And then we checked whether any of the weather conditions correlated with their basal metabolic state. And what we found there was quite interesting, sort of unexpected, that there were no correlations with the outdoor temperature. But there were some associations with the hours of bright sunlight during the day. And those were generally beneficial. If there was more bright sunlight during the week before the visit to our clinical center, then insulin resistance was improved and we saw some lower triglyceride levels, but all very marginal effects, I must say.
Parsing those effects, there could be a variety of things from exposure to sunlight. It could be vitamin D, it could be blue light, it could be UV light. How did you try to understand where the mediating effect was coming from?
Yeah, basically in this study we couldn't. Of course, we speculated about it. And my favorite hypothesis, at least, is that weather is nice outside, so there's bright sunlight outside. independent of the temperature, independent of the season, people tend to go out easier, go to work walking or cycling instead of taking the car. And that's my favorite hypothesis. But of course, there may be some other biological mechanisms there as well.
So it could simply be from increased physical activity. The weather's nice. It's nice to get outside. And instead of driving, you're walking.
Or the alternative is what you described in the beginning. So if there's a lot of bright sunlight during the day, that largely suppresses, among others, melatonin levels. So these melatonin levels help you sleep well during the night. So if you suppress them well during the day, they will be higher during the night and you sleep a little bit better, and thereby you improve your overall circadian or your day-night rhythm.
So bright light exposure coming into the eye in whatever form, whether it's sunlight or maybe even having the right temperature and intensity lights inside, will suppress melatonin rhythm further than if you're in dim light for a lot of the day, which many of us are. And that will then lead to a more robust melatonin rhythm at night. And that could, whether it's, actually acting directly on beta cell function or just having some effect through sleep, that could be part of the reasons why we see increased insulin sensitivity in this population.
That's a brilliant summary.
Do you think that vitamin D could be having an effect here?
It's a complicated one, and I don't know too much about it, but the most recent studies show that as long as you have sufficient vitamin D, it does not contribute extra to your metabolism.
Now that you've identified this, do you plan to take this research farther and do a follow-up study?
We're actually taking a couple of approaches here. So one of them is going more into detail. So from these cohorts, we also have detailed assessment of their metabolomics. So all the metabolites in their blood, measure them. And we can also make these associations to get a clearer picture of what is going on. The other approach we're taking is actually related to the reason we started these studies in the first place. And that's because I'm really interested in how rhythms can affect your metabolism and what happens in our, let's say, current lifestyle where we're continuously exposed to artificial lights, where we have to shift work. So what I try to do with this study that we just published is basically to look for very subtle naturally occurring rhythms. So we're looking at seasonal rhythms or other temperature rhythms during the year and see if that's already enough to modulate lipid metabolism and glucose metabolism. And apparently they do already. So those very subtle changes already have a quite big impact on your insulin sensitivity. I'm now trying to take this more towards clinic. So what happens when you're in a jet lag schedule, or what happens when you're in a shift work protocol? How does that impact your metabolism?
What are some other areas that you have investigated that might be having an impact on the activity of brown fat?
That's an interesting one. Yeah, so we already talked about cold exposure. We also talked a bit about heat exposure. And what I personally think, if you do heat exposure at the correct time, then you will also improve your sleep-wake cycle. You'll probably know that if you take a hot bath in the evening, that you fall asleep afterwards much more easily. If you correctly time the heat exposure, then you can possibly also activate your brown fat via that mechanism. But the other thing is just cold exposure. So cold exposure is not a very nice way of therapy. I've done it a couple of times myself, and I'm laying between these water-cooled blankets, and that's really uncomfortable. So the approach we're taking with that is timing of the day, the effectiveness of the cold exposure.
So you're laying underneath this cold blanket that's just under 40 degrees Fahrenheit or 4 degrees Celsius, and you do it for how long? And then what are the intervals that you're testing?
Yeah, so we're doing that for, on average, about 2 hours. And then what we're measuring is, for example, energy expenditure. So how much calories are you burning during this 2-hour cold exposure? Because your body has to use needs these calories to start producing heat by brown fat to keep your body warm. And so energy expenditure is a good proxy for at least thermogenesis in brown fat and maybe also other organs. And at the same time, we're of course looking at the plasma glucose and plasma triglyceride levels to see if they are changing and positively associated with this brown fat function or thermogenesis.
And the timing of that I would think matter. I do take a cold shower every morning after I take a hot shower. So take a hot shower, the last 30 seconds, sometimes longer, I'll do a cold shower. I would imagine that sympathetic activation might induce an increase in blood glucose temporarily, but does it also then increase brown fat activity, which would then be another mechanism to control blood glucose longer term? So is it a net healthy response in control of your blood sugar, even though if you were to measure, let's say 10 or 15 minutes afterwards, you might see blood sugar has gone up? That's what I would guess.
Me too.
What else have you either looked at yourself or identified as being factors that might either increase brown fat or increase its activation?
Well, you just mentioned the sympathetic innervation. That's really important. So cold exposure activates your brown fat through the sympathetic nervous system. So all the pharmacological strategies that mimic this sympathetic innervation are probably very effective. So there have been a couple of studies in humans already, but we need more studies to really determine which of the adrenergic receptors is involved, because it also determines how selectively we can activate brown fat, because these adrenergic receptors are also on other tissues, including the vasculature and the heart. Those are causing side effects that we don't want there. And if we're talking about metabolic disturbances such as obesity, basically it's not good to have any side effects there, because it's not a life-threatening disease. So basically no side effects are allowed here in this research area.
I would think that perhaps a light touch and being prevention-minded versus treatment-minded once a condition is started might even be a better approach here. But it's always hard to treat something prior to it being present.
And let's say it one more time, but the most effective way is just eating less and do sports. So move more. That's the most effective way to lose weight or to keep your weight at a healthy level.
Speaking about eating less, you've done some work on butyrate, and that reduces appetite and activates brown fat. And so what is the mechanism by which it's doing that? For me, how do you eat less? You eat food that helps you eat less. That is one strong way to do it. There are some ways to limit overconsumption, which also involves staying away from hyperpalatable food that drives the excessive intake of calories just due to pleasure. But then can you eat foods that make you spontaneously less hungry across the day? Butyrate has shown to do that. I didn't know that it was a brown fat activator. What mechanism is butyrate acting to increase brown fat activity?
What we think is happening is that it's signaling so that the gut is responding to the butyrate by producing hormones that are also released upon, for example, sugar intake. But this is probably a different composition of hormones or a much stronger impulse. And those are signaling to the brain, and then the brain responds by increasing the sympathetic outflow towards the brown fat.
I see. What are some ways that you can increase butyrate?
I think you're more the expert on that.
Well, I know a lot of fiber-rich foods. If you have certain gut bacteria present, then some fiber-rich foods, when digested by bacteria, can then convert into butyrate. That is one mechanism to increase butyrate production. We just tweeted about how a lot of products in the industrial food system are very high in propionate, and that has seemingly an opposite effect as butyrate. So that does things to decrease insulin sensitivity and increase hunger. That might be one of the ways in which the modern diet is actually having a negative effect on both of these things that lead to diabetes and obesity. So it kind of goes back to classic rules of eat good foods, not processed, high fiber, lots of veggies. Yeah.
In the end, it all comes down to that.
It's always nice to find tricks or areas that we haven't thought about before, because once you know some of these mechanisms, it can reinforce the dietary guidance that you have heard before.
I also find interesting is that all the regions in your brain that regulate food intake are also regulating energy expenditure at the same time. So you get always a dual effect when you do something that stimulates your brain. It causes satiety in your brain.
Those neural circuits that are involved in appetite, the other arm of them is affecting energy expenditure simultaneously. So these things are very tightly coordinated.
So the satiety effects are often coming together with changes in energy expenditure. And one of the things that I find really interesting are these dual agonists. So one of them is GLP-1 coupled to GIP. It reduces food intake and accumulates energy expenditure. And what we've shown already a couple of years ago is that GLP-1 activates your brown fat, or at least in mice it does. And GLP-1 is also one of the hormones that's probably involved in the beneficial effects of butyrate. So it all comes together again.
So just to then summarize what we had talked about, what were the main findings of your work?
the things we've shown is that there are rhythms in metabolism. In the paper we just published, we showed that seasonal rhythms, or actually rhythms are more like changes in the environment, such as bright light exposure, already impact your metabolism quite extensively. Where we're heading to is the more severe metabolic disturbances, such as during shift work and also in the aging populations, who also has lower rhythmic activity during the day. And we talked about brown fat. So brown fat is super rhythmic. We can use this rhythm to optimally activate brown fat. And there are also other strategies, other pharmacological strategies to activate brown fat. I think that's a summary of what we discussed.
Nicely done. Sander, thanks for coming on to the show. Appreciate your time and your work.
Thank you very much. And thanks for having me.
Thanks for listening, and come visit us soon at humanOS.me.